Hi, I'm Sue, and I'm here with Ryan. And today we'd like to give you a brief overview of the MidNite Solar products and help you have a better understanding of the solutions that we can provide for you with them. We make a lot of stuff. Charge controllers, combiner boxes, battery storage. We have about 1,400 different products to suit your residential solar needs. So to start with, we have accessories. For anything that you buy from us, if you need any replacement dead fronts or hole plugs, strain reliefs, you can get them all through our accessories. We've also got shunts of varying sizes, relays and resistors, charge controller brackets, e-panel backplates, and basically any other thing that you could need. We also have a full line of battery accessories. Battery cables that are pre-assembled from number 2 to 4/0. All of those are in UL-listed Cobra X-Flex cable. The battery capacity meter, which shows you an at-a-glance state of charge for your batteries. It's also very handy on things like forklifts in the S variety, which allows you to have it rigged with the key switch so that when you turn off that device, it will also turn off the LEDs on that battery indicator. We also offer hydrometers and 1,000-amp battery combiners, which Ryan will tell you a little bit more about.
All right, thank you, Sue. Yeah, the battery combiners basically come in two models. We have a 50 or a 100 millivolt shunt option. And basically what that is there's a 1,000-amp shunt in there, and different battery monitors, different inverters use the different shunts. So you need to look at that. Like the Classic, for instance, would use the 100 millivolt 1,000-amp shunt. So that's pretty clearly called out on our website, but definitely make sure you're picking the right one for the inverter you're using. The positive and negative bus bars, as you see included, there's one white and one red. Those are pretty massive tin-plated copper bus bars. They have 6 studs pre-attached that are 3/8 of an inch in diameter. You can drill the plate for additional fastening, and you can double lug the wires as shown in the picture below. You can also add the optional negative bus bars. So if you're using this as an example, the picture below, you'll see we're bringing in 4 strings of batteries, and we're feeding a handful of inverters and loads. So they have a bus bar on each side just to make it more convenient. It's rated for up to 300 volts DC. Max wire size per UL for bending room is 4/0. I have seen a lot bigger wire installed in this, but if the inspector does, look at bending room, if you have to bend the wire, 4/0 is the largest. It has knockouts for up to 12 of our MNE DC breakers. You can use anywhere from our 5-amp breaker with our breaker adapter all the way up to our 250-amp breaker. So that's pretty handy if you're doing multiple strings of, say, lithium batteries or AGM batteries. It's a good idea, just like in the PV modules, when we go over 2 strings, to start putting overcurrent protection on each string. It's the same in the battery world. So that makes a convenient place to do that. Or feeding, say, like 4 sunny islands, you could put the battery breakers in here. And they are all powder-coated steel.
Okay, our battery enclosures allow you a convenient place to store your batteries on a shelf. They're very sturdily built so that you can stack as much weight in there as you need to. We offer them in indoor gray steel powder coated and an outdoor white aluminum powder coated version. There's dimensions for all of these on our website, so you can see exactly what batteries fit well in here. But they hold anywhere from 2 8D batteries to 8 L16s, or 12 of the group 31 batteries. All of them include locking doors, and all of them are finished in powder coat. We offer a full line of AC and DC breakers, AC DIN rail mount from 5 to 60 amps and up to 3 pole. Our DC are DIN rail or panel mount versions, and rate from 1 amp to 250 amps. We have them available in 150, 300, and 600 volt models, as well as remote trip breakers. And we do offer ground fault breakers in various sizes. Additional accessories that go with those are some breaker protectors, and we also have a breaker adapter that will convert a 3/4 inch breaker to fit into a 1 inch slot. Also, we have the option of fuses and fuse holders. So if you need to go above the rating of our circuit breakers, the 1000 volt touch safe fuse holders designed for the 10 by 38 millimeter fuses are a perfect solution for you. They also fit in our combiner boxes that are DIN rail mount, and those range from 1 to 30 amps. We also offer a full selection of bus bars to allow you to bring in your wires and to do combining. Insulated bus bars from 60 to 1000 amps, uninsulated ground bus bars, shunt bus bars, combiner bus bars for your breakers and your fuses. As I said before, those go with our full line of combiner boxes that we'll talk about more later. And bus bar standoffs and insulators. If you do need more of those because you had one break or you had an issue with one, we do have those in our accessories as well, so those can be bought separately. Would you like to talk about clippers?
I'd be happy to. So we're going to talk about wind and hydro and wind turbines and clippers here a little bit. The classic MPPT controller is designed to work with wind turbines and hydro, but with a wind turbine or a hydro turbine, we have to do something to protect from overvoltage on our electronics. It's important to back up a little bit and understand MPPT a little bit and realize that an MPPT charge controller, as the battery gets full, will let the input voltage rise to make the turbine or hydro less efficient and prevent the battery from overcharging. Of course, if we do that, the turbine goes to too high of a voltage and we damage the classic. So what the clipper is designed to do is basically go in between those turbines and the classic. And it's designed to act as a fail-safe, an emergency brake, if you will. It's self-powered, it's self-regulating, so at the very first stage, it's going to make sure that it never lets through too much voltage for the classic you're running. And after that, it's also going to talk to the classic, and the classic's able to use the clipper to throttle the turbine down so there is not so much energy. We can actually slow it down, even stop it to the point if there's some solar in the mix as well. You might look out and see the turbine's not even turning, and that's because the solar is able to keep up and we don't need to wear the turbine out. All the clippers, we have 3-phase AC and we have DC. The AC clipper will rectify the turbine into DC for its output. They all have stop switches on the side, which you can kind of see there in the picture on the right. And they also come in 2 different wattage models. There's a 3 resistor version you see here, and then there's a 6 resistor version. Picking the right clipper can be a bit of a challenge, so we do highly recommend that, if you're not familiar or you haven't used it before on your particular turbine, that you reach out to Roy in tech support. He's our wind guru. He can help you pick the right resistance value for that turbine. But the clipper is essentially a fail-safe for the turbine that will protect the turbine from freewheeling and protect the charge controller from overvoltage. I think is the best way to put that. It does not drop the voltage of the turbine. So I have had that call a few times. Will the clipper take my 600 volt turbine and limit it to 250? It will limit it to 250, but the turbine's going to be at 250 as well. So it's going to be horribly stalled. So it is not a DC to DC converter. It is just a load dump for the turbine. Wind and hydro stop switches. Basically, just as they say, unfortunately the picture here shows a transfer switch sticker, but that's okay. It's the same box, it's the same slider switch, but essentially what we're doing is we're using one breaker as a run breaker, and we're using the other breaker as a shorting switch. So one of these breakers would get the turbine wired, the turbine would wire into the lug up here. One of them would get wired to to ground, short the turbine out, the other one would get wired to your battery or your charge controller. So when you flip the bypass switch, you disconnect it from the load and you short the turbine out at the same time. That comes with 63 amp breakers in there. They're the biggest ones we make. You could retrofit 300 volt breakers if you're using a higher voltage turbine. But remember, the breaker in this is not a overcurrent protection as much as it is a switch. And the Chinook. You want me to talk about this, Sue, or you want this one?
I can do it.
Okay, great.
The Chinook 200 is our new turbine. It's, as it says in the name, a 200 volt turbine. It comes in 12, 24, or 40, or 200 watt turbine. Excuse me, it comes in 12, 24, or 48 volts. It's designed for ease of installation. That diversion load allows you to wire that turbine directly into your batteries without an additional charge controller, so it is an all-inclusive system. We are also looking at releasing a 750 watt and 1000 watt grid tie battery charging version later on this year. The Brat charge controller, it's a 20 amp PWM battery charge controller with a 10 amp load circuit, or you can use it without that load circuit as a 30 amp charge controller. It's got some really great features on it. It can be used at 12 or 24 volts on flooded lead acid, gel, or AGM batteries. That lighting and load control I was speaking of gives you 16 lighting options, an 8-position switch for your battery settings so that you can specify the charging that you want, and a 30 amp controller with load paralleled. It has LED charge indicators so that you can see what it's doing state of charge-wise and make sure that your batteries are getting appropriately charged. And it is outdoor rated, so if you need a charge controller that's durable and can be out in the elements, this is a fantastic choice for you. Because it is a PWM, it does not do the tracking. You do need to match your solar panels to your battery bank to use this charge controller, although it has a bit of flexibility because it can be used up to 60 volts without damaging it. The kit is our smaller MPPT charge controller. It has an output of up to 30 amps, and it is perfect for a medium-sized or small renewable energy system, such as a cabin, boat, or RV. We offer it in a marine version, and the difference between the marine and the standard is the mounting structure. And what that does is it allows for some vibration resistance. It can charge 500 watts on a 12-volt system, 1,000 on a 24, or 1,500 on a 48-volt system. It has a lighting controller built in, and that goes to the full 30 amps, so as long as you don't need greater than that, you can use that lighting controller direct from the kit. And the load controller. It also features full auto gen start, so it will confirm that your generator has started by looking for a rise in your battery bank voltage. Would you like to discuss the string sizing tool, Ryan?
Yeah, I would. I'm not quite sure why it isn't finished loading, though. Let me back up a slide. Oh, there it goes. Interesting. So the string sizing tool for the kid, if you've played with the one for the Classic, they're quite similar. The kid is 30 amps into the battery, period. So if it's on a 12-volt battery, that's going to be like 500 watts. If it's on a 24, that's like 1,000 watts. So essentially, on the string sizing tools over here on the left in these yellow boxes, you're going to input your data, the wattage of the module you want to use, Fahrenheit or Celsius up here. The temperature correction coefficients, if you're not 100% sure on the modules, the defaults are going to be pretty close for any module out there. And, then you get to play around down here. These two parameters here are the ones that you're going to play with. You keep putting modules in series and hit your submit parameters and see what it comes up over here and tells you. A lot of good information up top, but in reality, these are the 4 fields down here you're really going to focus on. The max VOC, is it okay? Is it excessive? The temperature, the kid will go into hypervoc. So if this temperature starts to get down to a number that you see on any regular basis, then you've got too many modules in series, essentially is what this is telling you. So then we want to go back over on the left-hand side and we want to rearrange that and keep playing with it. And we want to get that to the point where, these numbers this is all green and this number looks good. This last thing here, these last two, the wattage and the number of kids required, just like on the Classic, the kid can be what we call overdriven or over PV'd. And that's a term that you'll hear a lot in the grid tie world. But the same can be done on our charge controllers. And what that does is allow you, if you're in an off-grid scenario, with PV prices being low, it allows you to add a little extra PV. So on a sunny day, sure, you're going to be clipping right at the 30 amp current limit. But on a cloudy day, you're going to get a little extra harvest, and that's when you really need it, when you're off-grid. You'll also notice that this number down here doesn't turn yellow or red until we go above 1.2. And the reason for that is because if you look at a solar module, if you look at the data sheet or the nameplate on the back of it, it's going to say like 220 watts. And then it's going to have this little term called STC, Sierra Tango Charlie. And STC stands for Standard Test Conditions. And that's in a lab at exactly 1,000 watts per meter squared. In the real world, we never have the blue enough sky. We never have the proper enough angle. Nothing really ever aligns to get anywhere near that 1,000 watts per meter squared as a general rule of thumb. So what we typically see is 800 watts per meter squared. And you'll actually start to see some modules with that on there as well. They'll have another set of parameters that they call like real world conditions. And that will be at about 800 watts per meter squared, or about 80%. So, again, we allow you to go up to that 1.2 just, because we know you're not going to get that whole nameplate. But the Kid and the Classic can be overdriven. So. You want the Whiz Bang Jr., or you want me to take that one? Oh.
Go ahead.
Okay, first day of PowerPoint. Apologize for that. The Whiz Bang Jr. basically is a current sense module that we designed. It uses a single wire to connect to the Kid or the Classic. It wires into the auxiliary 2 on the Classic or into the Whiz Bang Jr. jack on the Kid. It's designed to attach to the standard 50 millivolt 500 amp Deltec shunt. Now, what that means in a nutshell is that if you buy a MidNite E panel, you buy an Outback sheet metal box for their equipment, or you buy a Magnum box for their equipment, they're all going to use that same shunt. And it has a very, proper bolt pattern. Not proper, that's the wrong term, but a specific bolt pattern that we match to. That makes it much easier to install. You're not crimping ring terminals on wires or trying to get wires into that shunt. It's just going to bolt right on as shown, and it allows us to monitor the current flow in and out of the battery. And with that, we're able to do things like state of charge, an accurate state of charge, because now the charge controller is doing it. It knows the battery's temperature, can adjust for that. It knows when it went to float, so it can recalibrate to 100%. If any of you have used Trimetrics, you'll know that if you don't get it perfect over time, they'll keep dropping in percentage, and the battery can be completely full, and it might say 10%. So this is kind of eliminated by letting the charge controller do that work. That's a really nice way of doing it. You also get things like going to float on true end amps. So you can monitor the current actually into the battery and transition to float when that reaches a low level that's specified by the battery manufacturer. A couple of the other things you can do is global current limit. So if you've got a large scale system and it may be grid tied if battery backup, and you've got more PV than the batteries really can handle, you can set up a current limit in the Classics so that when the grid fails, that you won't exceed a certain amount of current into the battery. That's kind of a nice feature as well.
Okay, so the Classics. The Classic is our biggest charge controller. It has an output up to 96 amps when it's used with a 12-volt battery. It's an MPPT charge controller, which, as Ryan explained earlier, is maximum power point tracking. It's one of the most powerful controllers in the industry, and it's got a lot of flexibility and range of features. You can customize all of your battery settings and charge settings. It's a very reliable controller with a lot of functionality. We have 3 different models of the Classic, the 150, the 200, and 250 volt options. So that would be your input voltage. They can be used to charge a 12 to 72 volt battery bank and very adjustable as to what in between you want to charge there because you can customize the settings. Designed to work with solar, wind, and hydro. It does have a full set of wind curves already pre-programmed into it that you can use, or you can customize your own wind curve. It comes with arc fault and ground fault protection, Ethernet and cloud-based monitoring, which we'll cover a little more later. Now available in a talking Classic, which we'll also discuss a little further, and it is ETL listed for the US and Canada. So the Classic now speaks English. We are working on Spanish and French versions as well. It will give you updates on your state of charge, your input current, your output volts, basically any of the data that you need from it. It is customizable how much you would like it to talk, anywhere from not at all the way through what we call Chatty Cathy, which means that it will give you random phrases and different amusing, quirky little highlights throughout the day. It can talk to you up to about every half hour if you've got it set into that mode. But of course, as I said, you can turn that feature off entirely if you choose to. But it is nice to have it reminding you about your state of charge and to check your batteries to make sure that they are full. So it's a great little added feature. The Classic SL is our solar-only version of the Classic, also available in 150, 200, and 250 volt versions. It is slightly easier to set up and use than the full-featured Classic, but it does not have the ground fault. Or sorry, it does have the ground fault. It does not have the arc fault or Ethernet capabilities. And it doesn't come with a battery temperature sensor, although if you do want to add one, it is able to utilize that. It has a full graphics panel, unlike our previous version, which was the Classic Lite. So that's a very nice thing. It allows you to go through all your settings. A lot of people found that having the dip switches was more difficult than having the graphics panel. So we have added the graphics panel to the Classic SL. It does have a streamlined solar-only menu, as I mentioned, so it is a bit easier to set up than the traditional Classic is. The Classic string sizing tool, Ryan pretty well covered this with the Kid. There's not a whole lot of differences here. The functionality is essentially the same. Again, you want to make sure that you're designing within the Hyper VOC settings. You can overdrive the Classic a little bit, but you need to make sure that you're keeping your voltages within the specified parameters of the unit. Set up for any battery bank voltage, and it will help you decide how many panels in series and parallel are going to be ideal to go with your setup.
Yeah, and to expand on that, Sue, I didn't think to mention it in the Kid string sizing tool, but generally speaking, we always want to use the lowest voltage controller that we can use because it's going to be more powerful and usually less costly. And the closer we keep the input voltage to the battery voltage, the more efficient the electronics will be. And those two statements are true for any charge controller on the market. I'm not talking specific to MidNite here. So with that all being said, it's always a balance between PV voltage, wire size, and distance and cost. But just know that because it's 250 and it's a bigger number, it doesn't mean it's better. You know, it's a little less powerful, it's going to cost a little more money, and it's going to be just ever so slightly less efficient. I mean, we're maybe talking 0.5%, but still it will be a little less efficient. So ideally, generally, you always want to bring that PV voltage down as close to the battery voltage as we can and still operate. Now, that being said, I'm going to confuse you a little bit more and say that with MPPT controllers, any MPPT controller, we always want to leave a little headroom in the PV voltage above the battery voltage for that controller to work and work properly. Most of them are around 133%. So if you take the highest battery voltage you ever anticipate seeing, so if you've got a 48 volt battery, we might say 60 volts. If we multiply that by 133%, that's going to be the PV voltage as a minimum that we're going to want to see. The string sizing tool will let you know if you're too low on your voltage, but that's just something also to be aware of. The high voltage can cause a little more heat in the unit, a little less efficiency, and you have to be above a minimum as well.
Excellent point. Thank you, Ryan. Would you like to explain the power graphs for us as well?
Not really, but yeah, sure. Power graphs are very confusing. You look at this and your head hurts. You're looking at this and saying, why are there so many numbers? Why are there so many colors? Essentially, what you really want to be looking at, remembering what I said earlier about the higher the voltage, the little bit more heat, a little less efficient. The numbers that you're really looking at here are the black line on top. Those are the hard limits in the Classic itself. So if you're doing a 12 volt battery, the current limit on a 150 is going to be 96 amps. On a 48 volt battery, it's going to be 86 amps. You'll see lower numbers on these charts, and what that's indicating is that, let's say we take a Classic 150 on a 24 volt battery and we give it 120 volt MPPT voltage and we leave it there for 8 hours. The controller is going to get warm and it's going to see that temperature rise. It's going to back its current limit down to stabilize its output temperature at 25 degrees C ambient. And if you was to run it for 3 or 4 hours, that current might back down towards that 82 amps that you're seeing on that green line. In reality, in most off-grid systems, that's not going to happen because the battery is going to go and absorb and the current's going to back down anyways. If we go way back to that string sizing tool and that 1.2 Classics allowed because of the 80% nameplate, if you're doing a system where the controllers are going to run flat out all the time, similar to like a battery-based grid tie, and it's a larger system, then we may not want to load them to 100%, just to keep the heat out of the electronics. And I'm not saying that as a MidNite employee. I'm saying that in general, with any electronics, if we can keep them 80% or below on their ratings, they're going to be so much cooler, they're going to be so much happier, and they're going to reward you with a very long life. So heat is always our enemy with electronics, so just kind of remember that. Sorry for the tangent, but that I just kind of felt that fit in there somewhere. You want me to take software?
Please.
Okay, so MidNite offers a couple software packages. One of them is called My MidNite. It's a cloud-based system. The other one is called the Local Application, and that is a software that you install on your computer. Both of these are free, no charge to you. Both of these require the Classic be wired into your network with a Ethernet cable, hardwired into your network, into your router, if you will. You can use some form of wireless bridges between the Classic and the router, but you will need to wire it into the Classic. The Classic does not offer Wi-Fi, is the takeaway there. The difference between these two, My MidNite is cloud-based. You set up the Classic, it just sends data to My MidNite. You log on, create an account, and you get to go in there and look back through all the history, see all the data, and see what's going on. It's extremely useful for people that have remote houses or installers that have multiple customers. They can go on there and look at past history, or if the customer calls and says, hey, my battery's not getting full anymore, I'm not making it through the night like I used to. You can go on there and expand that little white box out and say, okay, well, I see that we were going to float every day at 11 o'clock, and then on, February 13th, you plugged in something because we never went to float again after that. And I'm seeing that we didn't even really get to absorb after that. So what did you plug in? It might just save you a trip to the site. It might help you understand. And it's also extremely useful just for the customer to be able to see an at a glance. There's 12 to 14 items you can see on there. Everything from state of charge to FET temperature to battery voltage, just a wide variety of stuff. The local application software is meant to be installed on a Windows-based PC. You can install it on Linux. Just know that our tech support's not going to support you installing it on Linux because they don't understand Linux. If you're competent with Linux, you understand what wine is, it shouldn't be a real big problem. There's some stuff on our forum about doing that. You can basically install Adobe Air and then install the local application under wine, and it'll run fine, 100% functionality, just like it does on Windows. The local app is basically a live connection to the Classic. It's talking as fast as it can possibly talk to the Classic, maybe 10, 15 times a second. So the gauges are moving almost flawlessly. You don't see the jiggle in them. They just move back and forth as things change. You get to configure the Classic from the local app. It's probably the biggie. Everything that you can do on the face of the Classic, virtually everything, you can do on here. You can build custom wind graphs. You can install wind graphs. You can import and export wind graphs to an Excel file for manipulation. You can actually dump the whole set of registers from the Classic. So if you had to replace one under warranty, or if you're an installer that uses the same type of batteries and stuff all the time, you could keep a file that you could install without going through and pushing all the buttons. Just kind of a nice way to interface with the Classic. If you're like me, my charge controllers tend to be out in my power shed, which is away from the house, so I can sit here in front of my computer and play with it when I need to, change settings, manipulate stuff, turn things off or on. Especially the auxiliary functions. If you're using them for some form of diversion control, you might need to fine-tune those now and then. So that's essentially it on the software. I will say that all the Classics, except for the SL, will work with this because the SL does not have Ethernet, as Sue pointed out. All of the Classics do speak Modbus. So if you want to do third-party stuff that's an openly published protocol, you can ask the Classics and the Classic SL's Modbus questions all day long, either by RS-232 or by TCP/IP. So if that's something of interest to a customer, have them reach out to us and we can get them the information for that.
Okay, MidNite E-panels. These are basically a balance of system for your inverter if you want to have a simple pre-wired, ready-to-go option that's easy to install. These come with the breakers already installed in them. It's a very, very simple way to mount your Magnum, Schneider, SMA, Samlex, or Outback inverters. We build custom E-panels that are compatible with all of those, so they just fit together like they were meant to be. Makes your wiring much, much simpler than if you were to try to use a separate, non-customized E-panel off the shelf. Anything you'd like to add to that, Ryan?
You pretty well covered it. I mean, it's basically a complete balance of system. It gives you all your AC bypass, your overcurrent protection, room for expansion with all of that in a very code-compliant manner. And as you said, we really do make them look like they belong together. The Snyder stuff will be painted color match to match the inverters. The SMA, as you see, is a molded plastic door to match the Sunny Island. So we take a lot of pains to try to make that look like it belongs together.
Our pre-wired systems. So similar to the E-panels, the pre-wired systems come with our customized E-panels, but already have the inverter completely wired in. The charge controllers are wired in. Basically, these are ready to hang on the wall and bring in your power sources and route out to your batteries, and you're ready to go. We do AC coupled, grid tie with battery backup, and off-grid systems. Similar to what we were stating with the E-panels, we do offer Samlex, Schneider, Magnum, and SMA inverters. Everything from about 2,500 watts all the way up to the large quad stacks of Sunny Islands, which gives you 4 of their 6,000 watt inverters for a very large system. And we can do even larger if you need a custom order. We've got an incredibly flexible build department. They can do semi-custom builds all the way to nearly entirely custom builds. Each of these are built to order, and rapid shutdown is available with all of them.
Yeah, and to expand on that, what Sue was saying about these being custom built per your order, that's exactly what happens when that PO comes in. Our technical support department or our applications engineer, depending on who's available at the moment, will review that, make sure that all questions have been answered, and they will assign a wiring diagram to that system. And the build department will build per that wiring diagram. They'll run a battery of tests on this system, high power tests, everything, and they will sign a checklist with all this test procedure, and they will include this wiring diagram with the system. This is a more simplified one for an SW, but if it was a quad stack or a large system, this may be a multi-page drawing. All the drawings will have a customer connection page, and you can't see my air quotes here, but we have what we call customer connection pages for AC and DC and communications. So it makes it very easy for the end user or the dealer that's installing this to look at that and say, okay, this is where this goes and this is where that goes. So we try to make it pretty easy for you.
Our mini DC disconnect. So this is one of our basic e-panels. It is designed to go with basically any inverter out there. If you don't want to go with one of the custom e-panels, this is a great fit. It's available with no breaker, a 125 amp, 175 amp, or 250 amp breaker already installed, which covers the requirements of most inverter manufacturers out there. The standard model has locations for either 3 panel mount or 5 DIN rail mount breakers. And if you upgrade to the Plus model, that gives you a space for a positive bus bar and 2 locations for breakers for up to 10 DIN rail mount, or a configuration of mixed 5 DIN rail mount and 3 panel mount. And it has mounting locations for the additional bus bars as well as for a standard shunt. So if you want to use it with our Whiz Bang or anything else that is with that shunt, it does have a location for mounting that. The Mini DC Disconnect 2X gives you 2 of the breakers in the 175 or 250 amp versions, an earth ground bus bar, and it has mounting positions for long and short bus bars, 10 DIN rail breakers, 3 panel mount breakers, and it also has the mounting location for, again, that shunt that you can use for current sense monitoring. We have a full line of small breaker boxes. These are great if you just need a little space to put a couple of PV breakers or some AC breakers. They're very simple to install and don't take up a whole lot of space. The baby box is large enough to hold 4 of our breakers, and it's great for using for retrofits, PV disconnects, or AC or DC distribution. It should be noted that this is not an ETL listed box, so if you do need that, then you would want to upgrade to the big baby. It's about twice as wide as the baby box, and it does include the ground box lug. It also gives you a little bit more space for wiring, which can be a little bit more convenient so that you don't smack your knuckles on things. It's a great general use enclosure, and it holds 4 of the 13 millimeter wide DIN rail breakers, which range from 1 to 63 amps. We also offer the quad box in case you need a panel mount breaker box. It holds 4 of the panel mount style breakers. Those are available from 5 to 100 amps. And we do not recommend using larger than 4 AWG in this. It gets pretty tight in there, so that's about the largest you'd want to use. Ryan, did you have anything else you wanted to add to that?
No, I think you covered it pretty well. The only thing I would add is that you'll notice that the cover on the quad box has force, not the cover, but the dead front that holds the breakers. The picture doesn't actually show the cover. The cover slides on over all of that. That comes out so you can mount the breakers and wire them. And what I found that works pretty well is if the wires come up through the bottom of the box, you can lean that out and connect to the studs on the back of the breakers. And then if you pull up on the top of the box and slide it back in and set the box back down on it, you can put the screws back in it. That gets a little tricky with number 4 wire. And if you're doing, like, say, if you're doing a couple classics, and you're going to use these for the breakers for the classics, do yourself a favor and get one per classic, because you will like yourself a whole lot more after you get done trying to install that number 4 wire. If you was to try to do 4 100 amp breakers in this, you'll be a little upset by the space, because it's a small box. It's made for a couple breakers or 4 low current breakers. I think that's about all I can say. But just don't try to put 400 amp breakers in it.
You want to talk about transfer switches as well?
Happily. The transfer switch, just as it says, it's made to transfer a load from a couple different inputs or a couple different loads from a single source, if you will. A couple examples of that would be, let's say you've got a well pump and you've got a generator and an inverter, and you want to be able to run the well pump directly off the generator. Or let's say you've got an inverter and you're off grid and you have a couple different generators. You want to be able to select between generator A and generator B. So essentially what a transfer switch does is it takes a common either load or source, and it will feed it from 2 isolated sources or loads, if you will. So if you've got 2 generators, they both come into this switch. The 2 generators never will physically see each other electrically, and only one can ever be connected to the load at a single time. Just basically a simple isolation switch. It's available in a 30 amp and a 60 amp model. Both will be 120, 240 volts AC. If it's 120 only you need, you can still use it, just don't use one pole of the breaker.
PV combiners. We offer a full line. Oops.
Sorry about that.
There they are. No worries. From the PV3 all the way up to the PV12. So this accommodates PV systems as small as 2 strings all the way up through 12, which can handle up to about 100 kilowatt commercial grid-tied inverter. So it does offer you a lot of flexibility there in the size of system that you want to design. The basic combiners go up to 1,000 volts, and we have breaker or fused models depending on the voltage needs that you have. We also make specialty combiners for the Tesla Powerwall and the Aqueon batteries. A little more on those combiners. Now that you can see the inside of them, you can see that the PV3, for example, holds 3 DIN rail mount breakers or 2 DIN rail mount fuse holders. The PV6 holds 6 breakers or 4 fuse holders, and the PV12 holds 12 breakers or 10 fuse holders. Then you get into the 250 models, which are available in the PV6 and the PV12. Those will hold half as many breakers as they say they will, since those 250 amp, technically 300 amp volt breakers are double pole, so they are twice as wide. Those also come with a more robust bus bar to allow for that extra voltage. The PV10 1000 is designed for using with the fuse holders and is rated up to 1,000 volts. And we have those actually from the PV3 size, which would be a PV2 1000, all the way up to the PV10 1000. So that can get a little bit confusing with all of the numbers and the different numbers of breakers that actually fit in there. If you have any questions at all, always feel free to call either our sales department or our technical support, and we'd be happy to walk you through which box will work best for your application.
Yeah, good point. And there's also a nice chart on the website with the combiners that lays it out in kind of a spreadsheet form, voltage strings, what it'll accept. So that can be pretty valuable as well.
You want to cover PV disconnecting combiners for us?
I would be happy to. So MidNite offers a full line of disconnecting combiners, and we call them high voltage combiners. We have a single disconnecting combiner that we'll talk about later that's not high voltage. But for the most part, the disconnecting combiners we're going to talk about are 4, 6, 8 string, 16 string, all rapid shutdown compliant, and they're all available with power supply boards added, and etc. The big takeaway is on all of our disconnecting combiners that we talk about in this category, they all come with strain reliefs, hole plugs, lightning suppression, all the parts you need to convert them from one model to another. So you're not going to be running to the store for any extra parts. You will be lugging parts home with you. And I believe we go into that here in a little bit. So this is one of the basic disconnecting combiners that I talked about that is not rapid shutdown compliant. It is not technically high voltage in that term. It's available in 3 models, the MNPV6 Disco, the MNPV6-250 Disco, and the MNPV6 Disco AC Micro. We'll talk about those down through. The PV6 is good for up to 6 150 volt breakers, and those are the DIN rail breakers Sue talked about earlier that are available up to 63 amps each. It will hold one 600 volt breaker and one AC breaker, for instance, with no bus bars. So if you had an older grid tie inverter and you needed a disconnect that would do the DC and AC all in one, you could do that. The 300 volt model, which we call the -250, will take up to 3 of the 300 volt DC breakers, and those go up to, I believe, 50 amps a piece, and you could get 3 of them in there. That is a different model. The PV6-Disco AC Micro. That's an interesting one, and micro really shouldn't be in there. If you look down below, you'll see it's got 150 amp bus bars. It'll take up to a 1/0 wire. So this is truly an AC combiner. It'll take 3 strings up to 50 amps per string at 120/240 volts and output a single output up to 150 amps. So you could have 3 pretty big grid tie inverters and combine them into this almost like a recombiner to go back to your utility feed, or you could use it for 3 strings of microinverters at 20 amps per string. So it's a pretty versatile AC combiner as well. Now we move into what we do call the high voltage disconnecting combiners. These are all birdhouse compatible. These all come with lightning suppression, fuses, fuse holders, strain reliefs, hole plugs, extra bus bars that you need, everything. They come in 4 string, 6 string, 8 string, 16 string. They come in a 3R style and a 4X style. You will notice that once you get to 8 string and above, they are what we call convertible. You'll notice in the picture here, there's the fuse holders are separated a little bit, and there's a couple negatives and a couple positive outputs. So you can configure this for, say, 8 strings into a single inverter, 1 positive, 1 negative out of the box. You could do 4 strings in and 4 strings in, isolated, and do 2 negatives and 2 positives out of the box. It could go to 2 separate inverters. Or you could do 4 positive and 4 negative in out to a single transformerless inverter. The PV16 is exactly the same, just twice as much fun. So you could do 8 strings to 2 separate inverters, 16 strings to a single inverter, or 8 positive, 8 negative to a single transformerless inverter. These are all available with the PSB, which I believe we talk about a little bit later, so I won't go deep into that right now. We'll talk about the SOBs. We call these the shutoff boxes. They're available in a 2-pole or a 4-pole. And what we mean by pole is how many strings or how many poles of the switch do we have. So in the picture here, you'll see we have a red in and a red out, a black in and a black out. This could work for a single 600 volt string into a grid tie inverter. If you use a 75 amp version, this could work as 2 separate 300 volt charge controllers, for example. The 4-pole would have twice as many terminal blocks. So if you had maybe a 10 kilowatt SMA inverter and you needed to disconnect but you did not need to combine, you could use the 4-pole 20 amp version. Or if you needed to disconnect, say, 4 classic 250s or Snyder XW 60 amp charge controllers for rapid shutdown and you needed something to deal with the bleed down, you could do the 75 amp version on the input of that, put the PSB up in here that we'll talk about later, and interface with our birdhouse. So the birdhouse is an integral part of all of this as far as 690.12 NEC goes. Rapid shutdown. The birdhouse is our 2014 NEC compliant solution. It interfaces with all of those combiners or SOBs or DLTLs we talked about earlier. It'll also interface with the battery breakers that Sue talked about that were remote trippable and can be used to isolate, say, a generator, which you'll see in a minute. The birdhouse is battery powered. It has AC backup for redundancy, and it also charges its batteries from the PV during the day. We do recommend 120 volt dedicated branch circuit to the birdhouse just so the batteries stay topped off, especially if you're in New England and you get a lot of snow and it might be a week before the PV gets sun again. Just nice to have that in there. The AC is the last thing that it's used, but it will keep the batteries topped off. The birdhouse gives you 100% positive feedback. I think it's maybe one of the only rapid shutdown solutions on the market that will give you positive feedback. It will actually let you know by through the cable that all the switches have opened and it is physically safe to touch. The birdhouse will also interconnect with an alarm system, so a fire alarm trigger could shut the birdhouse down, or vice versa. If the birdhouse is triggered, it could notify the fire alarm system so you get notification the system has been triggered. This is just an example showing how it would work electrically. The black is the power, the blue is the communications. The birdhouse does require its own communications cables between everything. It is a Ethernet-based pinout, but we try not to call it Ethernet cable because that typically indicates some form of digital communications. The birdhouse uses all low voltage, low current analog signals, so we're only using the pinout for your convenience. We're using the cable as DC communications. This is also showing how you could isolate a generator. And here's your power supply board and your battery disconnect module we talked about. You'll notice both have 2 jacks, so you daisy chain all this stuff together. The the power supply board for the combiners does have a upstream and downstream jack, and polarity on that is important because remember, this is charging the batteries downstream, so there are diodes blocking one from feeding another one upstream. So just make sure you pay attention to that. There is no concern over these two. They're both identical. The PSB, I do want to point out, if you're ordering a combiner for a specific job and you know it has to be birdhouse compliant, if you add -PSB to the part number, we will install that for you at no charge. The only charge you'll incur is the actual charge of the board. So we don't charge any labor to install it at the time of build. So that's kind of a nice feature, saves you some work out in the field. And it will be tested by us to make sure everything is functional. And I assume, Sue, you want to take care of the SOBs for us, little SOBs?
Sure. So this is our new rapid shutdown product. It's the most economical rapid shutdown on the market. It's very, very easy to install on new systems as well as retrofitting for older systems. It's a very dependable, fail-safe product. It does fail in the open mode, which does not allow power to come down from the panels, so it is very safe in that sense. The way that this works is you plug in the receiver module to the MC4 connectors on your panels, either on the first module in the string or onto the every module of the string, depending on which code you are trying to meet. It does meet the new 2017 code that goes into effect January 1st of 2019 for the modular shutdown. What the transmitter does is it sits on the PV positive line and it inducts a PLC signal into that line, which gives a keep alive system to the receiver, or signal to the receiver. And as long as it is receiving that, it does allow power to come from the panels. As soon as it does not see that signal anymore within 5 seconds, it will shut down that system.
think
So
you.
we covered most of this
Yep. Yep.
previously. So if you want to move on to the next slide, we can talk a little bit about the models that we offer. They are available in 600 and 1000-volt models for the receiver, and the transmitters are available in AC or DC power sources. So if you choose the AC, you can use anything from 90 to 305 volts. And with the DC transmitter, it can accept between 12 and 16 volts for a power source. We are looking at offering a 24-volt option as well, because we're aware that most of the inverters in the industry do have a 24-volt power source located right there within the inverter. The nice thing about these is they are designed to fit with the transmitter within the inverter casing. It's a very small item, and so that allows it to be concealed and keep your looking nice and tidy.
Yeah, and to expand on that, in a grid-tied inverter, in that scenario that Sue just mentioned, if the transmitter is in the wiring compartment, you can wire it to the 240 volts in the grid-tie inverter. So then utility failure does trigger a rapid shutdown. So it becomes very elegant. There's no cabling between the ground and the PV array. It's all done, as Sue mentioned, through PLC, which is a power line carrier signal that rides on top of the DC current. And the receiver's up there listening to it. It's sort of like a radio transmitter and receiver, almost like in your car. Very easy to install, and basically an AC power outage or shutting down the inverter with the AC disconnect is going to trigger your rapid shutdown, making it very easy for the firefighters.
We also offer a bleed down box with the MNSOB system. What this allows you to do is for any inverters that are not compliant to that rapid shutdown within 30 seconds, this will discharge the caps within the inverter so that they do meet that standard and make it safe. It includes the transmitter already, so if you are using a bleed down box, you won't need to buy a separate transmitter. You will only need to buy the receivers to go with it, and it is compatible with either the 1000-volt or the 600-volt version. Surge protection devices. The MNSPD is a Type 1 device designed for indoor or outdoor applications. It is fully sealed so that if you do put it outside in the rain, that won't hurt it at all. It's great for AC and DC electrical systems, and we do offer it in 3 different voltages, 115, 300, and 600. You do want to choose a voltage for your SPD that is above the voltage that you expect to normally see coming into it, because if you are using it with a higher voltage than it is rated for, you will put wear on those MOVs that are in there that are designed to stop the lightning strike from getting to your other electronics. So it's not just for renewable energy. You can use these for the AC coming into your house as well. We do recommend them because you can get lightning-style surges from the grid. They have a visual inspection with their blue LEDs. You'll see those light up when there is power coming through them, as long as that SPD is functioning appropriately. If it is no longer functioning due to wear or a lightning strike, those LEDs will go out, and then that unit needs to be replaced. It does have a 5-year warranty that is inclusive of it doing its job. So if you do get a lightning strike and that SPD is damaged and no longer functions due to stopping that surge, you can send it back to us within 5 years and we will replace it for free. These have a lot of applications, as I said. You can put them in your combiner box for your PV array protection, the DC distribution enclosure for your DC system protection, the AC distribution panel. So, for example, if you have an inverter, you would want to put an SPD on the AC out of that inverter so that anything that came in from the house electrical would be stopped before it came back and damaged that inverter. It's great for wind and hydro systems, especially wind. You know, you've got your turbine up there on a tall tower, and as you know, lightning is a big fan of anything tall out there, and so it is prone to lightning strikes. If you add one of these, it'll help protect all of your equipment from any lightning strikes that you might take to that tower. It's also great for standalone water pumping and telecom communications applications. And that wraps up our presentation today and should give you a good base understanding of the MidNite product offerings. Of course, if you have any questions, we're always happy to field those if you call our technical support line or our sales team.